Welcome back to the Lead and Allure Founder podcast. Today we are joined by Tom Trill, the CEO of Qualinx. Tom is a veteran of the semiconductor world with a track record with giants like Intel and a deep history of scaling hard tech ventures. He is currently leading the fundamental shift in wireless physics, moving the industry away from power-hungry analog radio towards a software-defined radio, DRS, model that promises to extend the battery life by up to 10 times. And so today we'll be discussing the mechanics of digital radio, the future of universal tracking, and why the silicon status quo is finally being disrupted. Welcome, Tom.
Thank you very much, George. Great to be here. Appreciate it.
Good to have you here. Likewise. So could you just tell everybody a bit about your journey, how you ended up with Qualinx, what you did beforehand, maybe some of the dark moments, the good moments?
Yeah. I don't think there have been that many dark moments other than those that we've all suffered from, in terms of market crashes in 2008 and so forth. But there's one thing about our industry in that it is cyclical, and it's predictably cyclical. Predicting when the ups and downs occur is a little bit of an art. There's no doubt about that. So my own journey, 32 years in semiconductors now, almost to the day. It was a bank holiday in Germany in May, 32 years ago, that I moved into my first semiconductor job. It was quite interesting. I wasn't an engineer at all, so it took me quite a substantial effort to figure out what a semiconductor was, but I still applied for the job and I got the job, and it's a hard industry to leave. So this company I'm with now, Qualinx is a pioneer in the domain that we call digital RF. I know we'll talk a lot more about this as we move forward. It's in so many different respects. It brings the entire semiconductor industry together in one place, in one business opportunity, and everything that characterizes our industry, from the sovereignty debate to supply chain risk to startup innovation cycles, it's all here in the sort of microcosm of what the industry is. So it's quite an exciting period for us.
Absolutely. Yeah. And I was listening to some stuff, a video kind of going through Tetrafab recently, which is, and I kind of want to get into that later. Maybe we'll go into but I'm really curious what your thoughts are about that space of things as well. Because seems what Elon's trying to do is super, the numbers have never been kind of calculated before and stuff. But yeah, first of all, could you just talk a bit about, digital radio, DRS concept, and how or why moving from kind of analog to digital is a strategic business shift rather than just a technical update?
Sure. Yeah. So what characterizes a lot of the IP within semiconductors is its ability to shrink, the transistor's ability to shrink and to follow Moore's law. That's essentially what Moore's law means. There are certain semiconductor technologies that don't shrink as quickly or as far as others. Embedded memory, either NOR or SRAM, they ran into this issue. And generally in the industry, the issue is called a scaling wall. So certain types of technology hit a scaling wall, and the effectiveness of the reduction in power, the increase in the performance of the transistors, and the physical size, the effectiveness of a shrink on those three characteristics becomes diminished. And while some suppliers or some technology have innovations that essentially work around, the workarounds are not sustainable. So in the end, your shrinkage, your ability to move down the geometry, that curve flattens out for you. Now, if you keep forcing the physics, it'll either break or it becomes economically unviable because you're not getting the benefit in the number of die per wafer from your shrink. So your cost base goes up and your output yield or physical size of the die doesn't return sort of an arbitrage on what you're trying to do economically. And furthermore, you don't get the technical benefits and the performance benefits because you have other constraints. Quite often, as a technology hits the scaling wall, a supplier will start to offload parts of the solution that are in digital. Digital is a soft target for an SoC where you have a component that doesn't shrink equivalently to the digital. So you offload digital components or digital IP to make room for the relatively large scale part of your IP that's not scaling in line. In the end, you're transferring the cost and the complexity and the integration and management, everything of these other IP blocks, you're transferring that responsibility over to the next constituent in your value chain. It might be your customer directly or a sub-assembly house, et cetera, et cetera. But the fact is the semiconductor supplier is no longer able to keep a fully integrated chip at the economics and power price and performance as promised. What
Okay.
is into analog RF? Analog RF hits the scaling wall.
Mm.
Fundamental novelty at Qualinx is the conversion of about 90% of an analog RF solution from the analog domain to the digital domain. As such, we get all the benefits of scalability.
Yes.
And CMOS scalability gives you intrinsically lower power transistors, smaller, more high performant transistors, and you pack more into a smaller area. So the technical, the product, and the actual economic benefits are all there.
Amazing. Fantastic. Cool. And when it comes to like power efficiency, could you share some kind of examples of how like a 10% reduction or a 10 times reduction rather of in power consumption can change the unit economics of, for a logistics provider, for example, managing millions of those assets?
Yeah. It's when you start to extrapolate the downstream impact of the power efficiency that we deliver through this technology, it's measurable in all sorts of vectors, economically for sure, power consumption for sure, and the impact on the environment can't be left unsaid either. So when we talk about a prime example of the cumulative effect in just power alone, from a marketing perspective, we like to talk about X, but in reality, it can be substantially more depending on what you're comparing to and what solution you're actually comparing to. And we've measured power, our power advantage, to be in excess of 20 or X at times versus the incumbents. Now, when you compare to many of the leading edge technologies from our competitors, typically around 28 nano or 22 nano, or even in the 40 nanometer range, there's still a large, significant amount of the supply coming from those legacy old nodes. 22 is our point of entry. And that is the point in which we see most of the industry, the legacy solutions kind of tapering out. And that's our point of entries. You can extrapolate for a moment just how far into the future digital RF will bring RF technology to consumers and our customers. Now, take the example of the logistics company that you just mentioned. While one of the very tangible benefits is that ultra-low power and therefore extended battery life from a positioning device that might be on whatever the logistics company is moving. And that's one of the most tangible, obvious solutions. But the true transformational impact that we have on such a customer is the shift in that customer's infrastructure. It's positioning, location, and tracking infrastructure. Just think about it for a moment. A logistics company today has got to have the protocols for connectivity globally. There's 6 constellations of satellites, as you know, that make up GNSS. So you have to support all 6. That's rather difficult because the 6th is Navik in India and it operates up at 2.5 gigahertz. Whereas the other constellations are all grouped around 1.1 to 1.6 gigahertz in frequency range. So even if you've kind of cracked a solution that can operate within that 1.1 to 1.6 range to cover the globe, you're still missing out on Navik. And even though there are only a handful of Navik satellites in operation today, the intent of the Indian government is to increase that significantly. So all of a sudden you see a proliferation in the hardware required just on GNSS connectivity, so that you have to have separate receivers for each actual constellation. The frequency ranges that are being transmitted need to be supported independently by independent hardware. Our technology, and right now we're just talking about the GNSS connectivity piece. There's IoT land radios where you have to transmit your location information to a gateway somehow. And that's normally an external component required by the system. And you've got complexities associated with moving from outdoors to indoors.
Okay.
The indoor tracking technology is proprietary in most respects, or else it's cellular. If it's cellular, you have to pay for a subscription, so there's a cost. If it's not cellular, it's typically either a Wi-Fi sniffing or a Bluetooth type implementation. Neither of those are particularly reliable, particularly if there's a heavy load of consumer devices hanging off your network, or if you're in a store, large furniture stores and so on and so forth. There's a lot of reliability concerns about determining your accuracy of your location from that type of technology.
Okay.
It's
Yeah.
it's cheap, but it's prone to reliability and security issues. So the other solution which avoids those issues is a very high-end system, typically referred to as ultra-wideband, super expensive. The indoor beacons all have to be hardwired, and the installation itself requires professional electricians to install. So it's not a very agile, it's not a very cost-friendly solution.
Yeah.
The challenges that are facing a logistics company today and all of these challenges can be solved at a system level, and the system has to include solutions specifically for each one of those issues. But more importantly, it also has to include a power source in order to keep all of these different subsystems operating safely, securely, and continuously. So what we offer to the industry is really a transition from a system level solution to a chip level solution.
Mm.
Our single chip can resolve any one of those issues that I just described, and it can do so in a very versatile and a very agile, low cost, and cost be measured in terms of money and power in a very, very low cost manner. One that very much replicates the economic class of a consumer device and the security class of a high-end enterprise device.
Absolutely. So what do you think the main thing is in between people switching to this, single kind of unified solution via like one of the most, cutting edge chips and staying to that kind of analog, infrastructure?
We don't really see that many barriers or switching costs. In fact, the switching costs are in favor of the customer ultimately, because you can eliminate significant amounts of infrastructure at the subsystem or the system level, or even at a module level. And you can eliminate a lot of that overhead. You can eliminate a lot of frankly, the industries that are built up around that and supply chains built up around those subsystems by having the capabilities and functionalities at the chip level. Furthermore, so you're taking all that working capital out of your operations.
Yep.
And furthermore, downstream for your customers, you're creating huge opportunities for innovation, because all of a sudden you free up a lot of space on your board and your roadmap allows you to shrink the device. You get more battery life, or you can reduce the battery or replace the battery, for example, with a harvester or a super cab. So it's very much a virtuous cycle of the elimination of cost and complexity within our industry.
Amazing. Good. And so semiconductors are high stakes, right, and capital intensive. And so could you talk about like the internal constraints required to lead a fabless silicon company in a market that's dominated by the legacy giants?
Yeah, pardon me. I think it's a very, very deep-rooted issue. And I've reflected upon this for many years now within the context of scaling up Qualinks. And my takeaway is that the startup's innovation and the startup's ability to execute, or the startup's innovation, the R&D and the engineering, and the startup's ability to build a innovative, transformative product is rarely the real cause for failure. The real cause for failure, as I see it through my lens, is the dependencies that a semiconductor startup has on very powerful stakeholders. Your ability to build a product. So the point I'm making, George, is that the jeopardy doesn't lie in incumbency of the legacy technology, because there's always such a strong market pull for innovation. that's not the weak point,
Hmm.
and we've seen it over and over and over through the history of humanity, right?
Absolutely.
Legacy dies out and new generations, new innovation, they come in. It's very, very cyclical. So I don't see that as a challenge for semiconductor companies. It's the environment and the contextual infrastructure and mentality that exists in the industry that causes the greatest jeopardy for a startup. And in my opinion, again, it's rarely about the novelty and the innovation because, if your novelty and your innovation isn't really there to generate a demand pull, it should be filtered out at the earlier stages of your venture.
100%.
Sure, yeah, a few slip through, of course, but with so many filters in terms of due diligence from investors, yada yada yada. There's a good safety net, particularly with there's a pretty good safety net, I would say. So it's those stakeholders upon whom you have a dependency, and those dependencies are through manufacturing, your EDA licenses, and your OSAT. That's the part of our supply chain that takes care of packaging and test. These heavyweights that are in your ecosystem are not motivated, typically not motivated or incentivized to engage with an emerging startup or a scale up.
Right.
Excuse me.
Right. Of
Yeah,
course.
that's one of the key issues and the key challenges. How do you get share of mind? And not only that, but how do you ensure that when things are going against you or you have these blind spots in what you refer to as the dark supply chain, when these issues happen, is that dependency you have, is it available to help problem solve? And quite often, unfortunately, but understandably, the answer is no. A rising semiconductor player doesn't get the share of mind. They don't have the economic clout. They don't have the volume and the purchasing power to get the heavyweights fully invested in unblocking any issues you might get. That's
Very
the issue.
interesting.
Yeah,
Okay.
it's not your incumbent supplier competitor.
Right. So yeah, solving those like fundamental kind of like, do you have innovation? Are you doing something new? Are you getting the shareholders on board with them, etc.?
Exactly right. And I think when you're in a place like Qualinx has been trying to enter this market with heavyweights, as you rightly described them, getting on the radar, getting attention from them, and is a challenge in on of itself. But resonating with them becomes the founders or the CEOs or the management team sole objective. And if you create that cognitive resonance with those that are on your paths of dependence,
Mm.
and even better, if you can generate some form of emotive resonance with them where you have a shared vision and an alignment, a strategic alignment of your goals, then that relationship becomes much more embedded and much more enduring through difficult periods and
Yep.
time.
Absolutely. And would you say that there's ever a disconnect between innovation and prioritizing innovation and what the shareholders' priorities are from their perspective? Because maybe there being, a difference between, let's say, like the best engineers
Mhm.
and the shareholders with the company. Because I know from a like kind of SaaS standpoint, that's like very prevalent right now with all kind of like investors, for example, saying, you need AI in like any product you're building, but it might not always be like the most important thing when you're building X product. But like, does that translate over to, your industry?
Yeah, it's an interesting question. This might be a little bit of a popular opinion or it might be contrarian. I'm not really entirely sure, but the benefit of AI is less about innovation and more about economics. I feel that time to development, time to qualification, time to redesign, time to compliance, or whatever domain you happen to be in. I think AI can be a tremendously helpful tool to accelerate your processes, essentially,
Yes.
and the distillation of data into meaningful information. Where I don't think AI in and of itself as a contributor is to the art of innovation. It can give you things within the cycle of innovation that are helpful and it can accelerate it, but it doesn't.
Exactly.
Yeah.
Yeah,
So
I agree.
I find your question really quite interesting from our perspective, and how we interoperate with our investors and the outside investment community. So we are very fortunate with our investors here. They've been with us from day one. We have 3 Dutch investors, and they very much have deterministic and purposeful capital, but yet it's patient capital. There's an understanding of what this industry needs to mature to a point sufficiently attractive for us to give a payback to our investors in whatever form or shape that takes. So we are fortunate. I think a lot of the deep tech investor or the VC communities and geographies behave similarly. There's an appreciation and an understanding of the return on investment for hard tech, and in particular semiconductors. But, it's not for the faint of heart, actually, this industry.
Absolutely. Yeah. I mean, that's good. You need people who understand kind of the actual application of it. Otherwise, I think it can, not give them a return as well if they're investing in the wrong places with AI. But there's also, like you said, massive kind of overhead or time consuming things that can be solved. Yeah, absolutely. So could you share some of the BS you still see in the IoT marketing world regarding universal connectivity and how your team's working to make that kind of a reality rather than like just a pitch deck slide?
I get exactly why you're saying the BS, the marketing stuff. And I think there is intrinsically a lot of BS in benchmarking in particular. We've seen that. We lived through the CPU wars and the sort of short-lived GPU wars, and now a whole slew of like NPU wars where everyone marches out a benchmark and a standard. And, like everything in life, it's easy in lab conditions to, generate a KPI. And then when marketing meets the KPI, all sorts of strange things begin to happen. And there's typically a departure from reality. So I think we're conditioned to that behavior. Now, I would say that in the position navigation and tracking sector in our industry, the GNSS industry, there's a lack of go-to metrics, go-to KPIs or standards. So we don't have a power per unit of whatever you want. We don't really have a default yardstick. So that eliminates the potential for lab-based marketing campaigns. We'll use that terminology for it right now. And there's nothing against it, by the way, because in certain segments, everyone looks to a lab-based thing, right? So long as it's apples to apples, that's fine. But the departure from reality is not fine. We have these 2 different paths that says, yeah, on paper in the lab, it's here, but in reality, it's going to be over here. So we never want to have our engineering customers make an adjustment for what they might think is marketing fluff or BS or in lab conditions. We want them to have real hard data.
Empirical.
Yeah,
100%.
exactly. Yeah.
Yeah.
So with our technology, our digital RF technology and the way we approach the market is that we have a capability of unlocking the hard data, the raw data, as we receive it prior to any smoothing or prior to any algorithm adjustment of the data to give a nice, clean output. So we have that opportunity in the architecture to make that relatively accessible in more of a software SaaS type engagement with us.
Yes.
And we all know that data is a very, very valuable resource. And if an algorithm is distorting that data, it should be for the right reasons. And not every end market requires a distortion in the raw data. In other words, it's only those that require a smoothing of the data that should be serviced in that manner. There are a lot of very sophisticated systems that do not perform well if your data is smoothed. You bring me right back to the point of a lack of go-to standards or yardsticks in GNSS. And maybe that's something that we can lead. Maybe we can talk about milliwatt of power consumption per fix or per meter of accuracy or per hour under certain conditions and give the industry a yardstick upon which to measure the available options, and it's easy to establish that. And
Absolutely.
it means that the data and the specs that you're giving to your customers are more reflective of the realistic in the reality of what they'll see in the field, and they can make better decisions, and those better decisions translate into better products for us, and hopefully an avoidance of dead design cycles.
Interesting. Yes, absolutely. Yeah. And so as we look forward into the rest of 2026 and years to come, could you share some details on like the primary mission for Qualinks, and as you move away from R&D into bigger kind of massive commercial scaling?
Sure. This is quite a pivotal year for us. We go from an engineering company to a product company, where we're actually selling mass-produced semiconductors. The ultimate vision that we have here at Qualinx is that we um, evolve the connected edge. We re-envision the connected edge. And what that means is, and I'll give a sort of a metaphor analogy about this.
Absolutely.
You ask 100 people to define the IoT and you get 100 different answers. But there's a common denominator, and that is connectivity and interconnectivity. And the barrier to having an always on or a quasi always on connected edge IoT is power and price and the physical size of that connectivity or interconnectivity solution. And today we can achieve it, but it's at a system level. And because it's at the system level, the power budget and the money budget you need for that, plus the maintenance thereafter, is very complicated and high cost and high power. By bringing all of that functionality down onto a single chip, you fundamentally shift the entire industry all the way from where we are in the value chain, all the way downstream to end users, who now all of a sudden have capabilities that were previously only accessible to an enterprise with the system level and the security measures that they implement, all the way down onto a tiny chip measuring 7.5 square millimeters.
Amazing. Yeah. So interesting. And so what are some of the systematic changes that you would like to see in the semiconductor ecosystem to better kind of support the next generation of hard tech entrepreneurs?
Yeah, this is a very challenging question to answer because there's such regional embeddedness in semiconductor supply chain and value chain. Like we touched on earlier, the jeopardy for a scale up or a startup is not always the competitors that you face. It's those dependencies that you have around you to get you there. And typically it's not the venture capital or the liquidity either, because that's typically accessible if you have a credible and viable innovation. Those dependencies in our sector are specifically your foundries and your access to foundries. Every startup is fabless nowadays. Secondly, is the affordability of the EDA tools, the design tools that are necessary to build a semiconductor and ensure that it's capable of being mass produced without any issues. Those hurdles are incredibly high for so many different reasons. And I'm not sure if systemic change can be the type of systemic change can be identified clearly, but there's a responsibility upon the entrepreneur and the startup to ensure that their value resonates with those stakeholders. So that once and we talked briefly about cognitive and emotive resonance, but you have to establish that in your relationships throughout your ecosystem, but in particular where the jeopardy is the highest, and it is in those two situations for a startup. To pay millions in EDA licenses in a short couple of years as a startup represents typically a large percentage and large ratio of your A series. And that budget in and of itself can be crippling for a startup. Same getting a direct relationship with a foundry, typically very, very difficult. And if it is possible, then it becomes almost a full-time job, almost lobbying for attention. So the answer that's given to available to a lot of scale-ups and startups is to go through aggregators or intermediaries who serve a purpose, but I feel overall feel that they are more of a barrier to efficient time to market for a startup, because you have to pretty much divert away from the mainstream through an intermediary and do everything their way and pay them a lot of money as well. They're for-profit
Yep.
organizations.
Yep.
And then once you have a investable MVP, for example, you then have to report and you have to do almost an entire cycle and life cycle exercise again to get back into this mainstream mass production line. I think the powers that are, if they could wave magic wands for people like me and the team we have here, it would be to address that issue, to fix that. It's
Mm.
capital inefficient, it's time inefficient, it's process inefficient.
Yeah.
And it is a choke point.
Yeah. And more to be focused on with customers understanding issues on the product.
Right
Def-
on.
Yeah.
Yeah.
Yeah. Maybe there's some sort of AI technology that can like actively
Yeah.
report based on, that would be a good kind of a massive efficiency win, that can report based on the changes you're actively making and tie it
Yeah.
to their kind of KPIs at the same time.
Right on.
Would be useful, right? I guess, yeah, I have one more question, kind of future looking, but I guess before, I'm curious about your thoughts on the hot topic of now, which is tetrafab.
Everything Musk said he's going to do, he's done, right? So, yeah. I remember when Tesla's first started talking about FSD, full self-drive capability. They were using NVIDIA. I forget which one it was a fairly powerful GPU solution from NVIDIA, but they were consuming tens of watts to do their job, right? And then I believe Elon Musk set a target of 5 watts. He went and hired some very, very smart intellectuals in the semiconductor industry, designers, and he built a full self-driving an FSD chip for sub 5 watts. So this was orders of magnitude lower than the commodity off the shelf or the merchant silicon that was available at the time. Now, incidentally, I read, and maybe it's true, I don't know, but I don't know for sure, but now he's going back to NVIDIA again, which kind of makes sense, with the rate of change in the computational capability of an NVIDIA's solution versus the environmental demands on the car. I think one is faster than the other, but it's not surprising but interesting that if he is going back to NVIDIA. So I don't think it's a case of if, I think it's a case of when and how fast he builds his fab, and his sort of vision and determination to fully vertically integrate everything in his master plan
Mhm.
is being revealed step by step.
Mm.
I do think it's exciting. I think anything that kind of destabilizes an industry that's getting mature in its systems, in its habits, in its culture. Every system like that needs a little bit of a shock or a big bit of a shock in order to rebuild and come out stronger and be more
Absolutely.
resilient. So yeah, there's an author called Taleb, I think Taleb, who wrote a book called Anti-Fragile. You might be familiar with it, but it's about how systems recover after shocks, and they come out less fragile.
But yeah, I think exactly. He seems to be good at that across any industry, right?
Totally. Yeah.
Yeah, and it's going to be focused on the design and packaging, if that's correct, right? So that, and not obviously the whole process, because otherwise they would have to get all of the EMV machines, like 500 was it also? But yeah, and it will, I guess, increase efficiency a lot because they'll have their own departments in-house to go back and forth, shorten the time kind of involved. Good. Okay. Yeah.
So anybody that invests in that type of process set within the entire process flow of a semiconductor is never going to be patient enough or willing to pay the premiums for the supply of a discrete chip or a wafer. So I think it's inevitable that further vertical integration is on the cards for whatever is happening there.
Absolutely. Yep. And so, last point, if you could talk to a fellow executive who's currently navigating their first major hardware scale up, what advice would you give them to ensure that they stay focused on the core mission despite noise in the market?
This is a cliche. It's old. You can read it from 100 years ago, probably. Stay the course. Execute. It's about execution,
Mhm.
and never go more than one deviation away from your roadmap, from your plan of record. And only do that if there's an acceleration to your roadmap. Short-term financial gains from a deviation from the plan of record they're nice, but they're never worth it unless you can accelerate the entire venture as a result of that deviation. And the only way you can confidently do that is by ensuring that the foundational logic in what you're trying to do, the problem you're solving, and how you're going to solve it. If that foundational logic is there and the capabilities and the resources are there, it's at that point where you can kind of say the R&D piece is done and now I'm in execution mode. And once you're there, then don't deviate no more than 1 degree away from the plan.
I guess it's easy for any entrepreneur to do, isn't it? Because it's like we have this natural shiny object syndrome to kind of be like, oh, there's something else that can improve this. But a lot of the time it is just literally, this is been done. This is the thing that's going to work, but it's a matter of kind of waiting it out. Okay,
Yeah.
good.
And just to be clear, I'm I'm not evangelizing that you shut down and push back the shiny objects. I think an assessment of every shiny object is very, very important, because it makes you stress test your own conviction, but it also might add something to a roadmap later. I think the real importance is to keep it to yourself and don't distract those that are in the middle of developing your roadmap and delivering your roadmap, because
Right.
they
Yep.
don't need that distraction and that stress. Certainly brainstorm around it, but don't mandate it. And if you do, make sure you only do it once or twice.
Yeah. Otherwise it'll be boy cried wolf, end up doing everything, Yeah.
Yeah, it's
Amazing.
about focus and execution, but you can only get there if you have a conviction that the foundational stuff is in place. It's rock solid.
Absolutely. Yeah. Well, thank you so much for jumping on and discussing your company, the ventures, the industry. It's been great speaking with you.
Likewise, George, I appreciate it. Thanks so much for the conversation. Really, really intriguing for me. Thank you.
Brilliant. And thanks again to everybody who tuned in. This has been the Lead and Allure Founder podcast with Tom Trill at Qualinks. I will see you on the next one.